Hi guys, before we can render anything in 3D, we really have to discuss some of the 3D math needed for that, and in particular matrices. So in today's video I just wanted to give you this general intuition for what is a matrix in computer graphics and why do we even use them. So let's get started. First of all, let's look at some examples of matrices. Generally speaking, matrix is just a way to store values in columns and rows. So for example, here on the left you have this 2 by 2 matrix, in the middle that would be 3 by 1 matrix, and on the right side it's your usual 4 by 4 identity matrix. But what really is a matrix in terms of a computer graphics? And the very nice way to think about it is that a matrix is just a way to describe some transformations that we want to make to a point. So for example, let's say we have coordinates of some point in 3D, and we might use a matrix like this to describe how we want to transform it. What does it mean? You can think of each value inside of a matrix somehow determining what do we want to do with either x, y, or z coordinate of a point. And depending on the specific value in specific cell of a matrix, transformation of each of those coordinates will be different. So this sounds very obscure and abstract, but don't worry, when we get into the actual calculations it will make more sense. Okay, so let's say we created our matrix and somehow we described the transformations that we want to make, and what's next? Well, next we want to understand how to actually apply the transformation, right? And it turns out that to apply transformations we just need to multiply two matrices. So in the first matrix we have our original point coordinates x, y, z, and second matrix describes the transformation that we want to make to this point, and so we just multiply two matrices, and in the end we should get our transformed point coordinates, right? Okay, let's do some math to see what this matrix multiplication resolves to. But even before doing that, if we think about it, we were saying that we use matrix to describe transformations to a point, and by multiplying matrix by point coordinates we get a transformed point. So even before doing any math, we should probably understand that result of this transformation will be just a 3 by 1 matrix which will have a transformed point coordinates, right? Are you still with me here? So let's now do some math. So in order to calculate the new x coordinate of a point, we need to multiply first row of the matrix by the first column of a second matrix, right? As you can see them highlighted here. And to calculate the new y coordinate, we need to multiply second row of the first matrix by first column of second matrix, and to calculate the new z coordinate we need to multiply third column of the first matrix by the first column of the second matrix. So if we resolve those equations, then we just get new point coordinates, which in our case just x, y, z, so they're exactly the same. And that's no surprise, because the matrix that we use to describe transformations, it's a so-called identity matrix. And this matrix just means that don't do any transformations and just leave everything as is. So in terms of your regular math, you can think of this identity matrix as just 1, right? And so for example, if you want to multiply two integers, like you maybe multiply 5 by 1, you just get 5. So identity matrix is analog of that. You multiply point by this identity matrix, you get the same point. So no transformations are applied. So The next thing is that you might be thinking, so this whole matrices thing, it kind of sounds a little bit unusual to me, especially if you have your high school math background. You're probably just used to normal calculations and formulas, and you might be thinking, why can't I just, write some formulas in code and just transform the point coordinates that way without really using this fancy matrix syntax. And the truth is that you can actually easily do that. You don't have to use any matrices, but there are some downsides to that I wanted to let you know about. So first of all, your code are going to be bulkier and harder to read if you don't use matrices. And the reason why that is so is that on the previous slide, we were doing these calculations, and you can already see that formulas to transform each of the point coordinates could be relatively long. And in this case, we are just using one matrix to transform them. And in computer graphics, it's quite common to use multiple matrices to transform a point coordinates. For example, it's not uncommon to see, 4 or 5 different matrices multiplied together. And so if you were to write similar code without matrices and by just typing in formulas and transforming each of the coordinates one by one, you will have quite a long shader function to do it, and it will be very, very difficult to read. And you probably will not kind of really feel it unless you do it. But from my personal experience, I actually tried not using matrices when I was just getting started, and it was really painful and extremely hard to debug. And especially if you work in a team and you have many people working with you, and someone has to read your code in shader, they would have extremely hard time understanding what you're doing there. And so I would just say that using matrices is much more concise and understandable, and you can simply look at the matrix and values in the rows and columns, and with enough experience you can already understand what type of transformations are going to happen using this matrix. So that's a really powerful tool. And the second thing is that if you don't use matrices and don't get used to this convention, then you will really have trouble reading documentation on the topic. And if you read any book or any blog post or anything on Stack Overflow or similar websites, then everyone assumes that you just using matrices for doing these transformations in computer graphics. And if you're not familiar with this notation and you are not used to the way of thinking in terms of matrices, then you will have really huge trouble understanding the documentation that you will for sure need to read. So you will just complicate your life there in many ways if you don't use matrices and don't get used to thinking in terms of them when you write your GPU code. So hopefully at this point you are already convinced that you really should get into the matrices. And so if you are, then let's keep going and let's discuss some of the matrix multiplication rules that you really have to know about to avoid getting into trouble. So the big problem with matrix multiplication is that the rules of them are very, very not intuitive. And if you again just used to your high school math with multiplication of integers and just normal algebra, then matrices are quite different. So let's get into the stuff. First of all, two matrices can only be multiplied only if the number of columns in the first matrix matches the number of rows in second matrix. So what does that mean? So for example, in our earlier example, we are multiplying two matrices. In the left matrix we have this 3 by 3 matrix which has 3 rows, 3 columns, and second matrix has 3 rows and only 1 column. And so as you can see, the multiplication was only possible because our first matrix, our left one, had a number of columns that was equal to the number of rows in the second matrix. And for example, if we wanted to multiply something like this, then it's not even mathematically possible to multiply those two matrices simply because first matrix has only 1 column and second matrix has 3 rows, and so those numbers are not equal, and therefore it's not the multiplication of those matrices is not even possible. So the second rule is that when multiplying matrices, order of operations matters most of the time. You can't swap the left and right operands in multiplication and expect the same result. If you multiply matrices on the left side of this inequality, then you'll get one matrix, and if you multiply two matrices on the right side of inequality, you'll get different matrices. And we'll actually do the math right now to see how that is. And unlike operations with integers, right, for example, if you multiply 5 by 8, you get 40, and if you multiply 8 by 5, you also get 40, and again, that's not the case with matrices. So let's now do some math and see why is that. So let's first resolve the left side of this inequality. To multiply these matrices, we will get another 2 by 2 matrix, and let's see how we get each element of this resulting matrix. So to get this top left cell value, we multiply first row of the left matrix with the first column of second matrix, then moving to top right cell, we multiply first row of first matrix with second column of second matrix. And then for bottom left cell, we multiply second row of first matrix with the first column of second matrix, and then for the last cell, we multiply bottom row of first matrix with the last column of second matrix. And so if we resolve all that, we get new 2 by 2 matrix. Now we are resolving these operations using matrices in different order, right? So we swapped operands. And so if we do all the calculations, we get also 2 by 2 matrix. And so to put them on one slide next to each other, we see that the first matrix that we get was this one, and second one was, very, very different matrix. And so now you can probably see that, changing the order of operations, changing operands of matrix multiplications, it's going to change the actual result, which is very, very not intuitive. So let's now look at the third rule. And it is that matrix multiplication goes from right to left. What does that mean? So let's say we have these 3 different matrices, A, B, and C. And for example, let's say A matrix contains our x and y coordinates for a point, and matrices B and C describe some transformations that we want to make to this point. So let's say we want to first transform our point by matrix B, and then we want to transform the result of those by matrix C. What do? If you're used to just a normal algebra, you might think that you might just multiply, matrices one by one, right? A by B and then by C. And you might be thinking that those are going to give you the result. And unfortunately, as with everything, with matrices, that's not really the case. Since matrix multiplications goes from right to left, in fact, what we are going to get is matrix C is going to be multiplied by matrix B, and then the results of those multiplications will be multiplied by matrix A. And what's also interesting is that this is actually not even a mathematically correct equation, because result of multiplication of C and B is going to be another 2 by 2 matrix. And here we have a 2 by 1 matrix. And as you remember the rule 1, we can't really multiply 2 by 1 matrix with 2 by 2 matrix, because number of columns in this matrix is 1 and number of rows in the resulting matrix here is going to be 2. So that's not even a correct mathematical operation. And so in order to properly multiply A by B and then by C, we actually need to apply multiplication like this. So first we have this A matrix, it's the rightmost one, and then we now are going to multiply it by B, and we are going to get another 2 by 1 matrix as a result of this multiplication, and then finally we will apply multiplication by C, and the final result will actually be the one that we were looking for initially. So as you see, matrix multiplication can be really tricky, and in particular when it comes to debugging, a lot of time you might be seeing weird errors, and then probably the first really place to look is your GPU code, and just to ensure that you actually followed all those rules that we talked about. And again, those rules were not the exhaustive description of all the matrix multiplication things. Those were just coming from my personal experience that I struggled with the most, and probably if you just follow these 3 rules, you should be able to do like 80% of the things you would ever want to do on a GPU most of the time without getting into trouble. And the next thing that I wanted to share is just some resources on linear algebra and matrices in particular. First one, probably if you coming into this computer graphics field for the first time and you're really not used to this linear algebra way of doing things, and you really want to understand how everything really comes together, then the great place to start is this Essence of Linear Algebra playlist by 3Blue 1 Brown on YouTube. This is of course free material, and here, as you can see, it has not so many videos. You can probably watch them in a couple of days if you really wanted to, and he really has this nice visualizations of things that gives you really this nice intuition about how things work and why they work that way. So would highly recommend starting here. And then the second thing, which is more formal, your kind of sciencey linear algebra way of doing things, is this book called Immersive Math. The reason why I really like it is that since it is an online book, they use WebGL to visualize the concepts they talk about, so that you can, for example, when you read this book, there are some visualizations that are interactive, so you can, drag vectors and in different directions and see how values of formulas change depending on where you drag them. And The second thing why I really like it is that this book is actually, it's very specific for computer graphics, so it really discusses the things from the perspective of computer graphics, and it keeps in mind, it gives you really nice examples of what types of things you might want to use this math for. So for example, it talks about this, for example, how GPU figures out which pixel lies within specific triangle, and it says, okay, so here is this formula that we discussed, and here is how it is actually used in computer graphics. And I find that this extremely helpful, because oftentimes with math you get this kind of explanation of some formulas and all this math behind it, but it's really not clear when and why you would ever need this formula in real life to solve some real problem. And I think this book actually does a great work explaining that. And so, for example, another example that I wanted to give you is kind of, it uses this example to show you how ray tracing works, how actually intersection between specific ray and some sphere, some object on your screen are calculated. And so, you know, following these examples, you really can see how all this kind of math actually applied in computer graphics. So this math, it's not abstract here, right? You really, with these examples, you see how it's really used in the industry. So that's a great book. But as you can see, this book is kind of heavy on this math syntax, and you know, if you're not used to that, it can really give you this headache. And so, like I said, if you just are getting into the field, what I would recommend is that first do watch this Essence of Linear Algebra playlist, and then just start building things. Follow my videos. We will be building them together, and after you build some things and you get this feeling for how it actually really is to work with that stuff, then maybe you can start looking at this immersive math book with already understanding a little bit what it is like to do this linear algebra in code. So that's all from me for now. I hope you learned something in this video, and if you did like this video, leave a comment, let me know what you think, and of course subscribe to the channel, and I'll see you guys next week. Thank you, bye.